Welcome, everyone. So we're just 1 minute away from 12, and I'll start with the preamble. If you guys have not attended one of these sessions, I'll pop this on the screen. This session will be streamed live to YouTube, and it is available for playback. So just be mindful and respectful for what you say, just in case there's anything sensitive you say on the session. Also, the people who are attending the session, as well as myself, we're volunteering our time to help people raise awareness of process safety and improve their performance in process safety in their everyday lives. We try to choose different topics every month or different incidents, and it's all available for catch up, and it's a place to learn from each other. So again, just be mindful that everybody is sharing their time free of charge here. So if you disagree with somebody, be respectful in that, and we can all move forward together positively. So it's just gone 12 o'clock. Welcome everybody to the Process Safety with Louise session for April 2022. We've changed the session style a little bit, probably from last time you attended. Most of the time we're trying to do the sessions at noon UK time because that works best for a variety of audiences. We're going to start with an introduction to myself in case you haven't been to one of the sessions before. And then I'm going to go through a safety moment, which will be about half an hour. And then after that, the floor is open for questions. You can ask questions on either the topic that I've presented or the incident I've presented, or give some reflections, or you can ask it on any process safety topic. And if I can answer, I will. And if I can't answer, I'll point you in the direction of the right person. We'll wrap up at about 10 to 1, if not before. And as I said in the introduction, these sessions are for you guys to learn and to share and to ask questions. So if there's no questions, we'll be wrapping up a little bit earlier. Use the Q&A so that it makes it a little bit easier for me to answer the questions after 12:30. Before we start, I'm just checking, can you guys hear me and see me okay? Got a few in the chat. Morning. So yes, excellent, you can hear me and see me. Otherwise, I'm just talking to myself. Wonderful. Thank you, everyone. So an introduction to myself. My name's Louise Whiting, and in 2019, I founded a company called Barberton Limited. I provide independent process safety services to a variety of companies, and I do these 1-hour sessions a month to try and help people who do not have access to a strong process safety network within their company to come and ask open questions and get free advice. Okay, this month, we're going to be looking at something a little bit different. So last month, we looked at a specific incident, and I spoke to you about how that incident happened. But this month, something really interesting happened. So I saw a post on LinkedIn by James Pomeroy, and it was about this, this podcast. And I didn't have high hopes for listening to it, but because James recommended it, I listened to it, and actually I was hooked. I really enjoyed the podcast. I really liked the way that Tim Harford described the incident, drew us into the story, and then explained how things went wrong, and explained actually what really the lessons were here, rather than what the lessons people have taken from the incident are. So just a summary for anyone who hasn't listened to the podcast, I don't want to spoil it, but the Hyatt Regency was a hotel in Kansas, and they had 3 skywalks constructed above the lobby area for the hotel. It had been built a year before, and on this evening they were having a dance competition, and at about 7 o'clock at night there was a loud noise was heard, and then very shortly after that the 3 skywalks fell down. When they completed the investigation as into what happened and how these skywalks failed, they found out that there had been a minor design change during the execute phase of the project. So there were 3 skywalks, and we had the upper one, the second one, and the lower one. And the upper one and the lower one were supposed to be hung from the same rod. It was supposed to be one continuous rod, but during the construction, they had problems constructing this one continuous rod. So they phoned up the engineers and said, look, you know, what if we hung the top one from one rod, and then we hung the other one from the top one? The engineer said, doesn't sound like it's going to be a big problem, but submit it in writing. It turns out it was never submitted in writing. So the management of change process wasn't adhered to formally documenting, although the change was requested and it was apparently partially approved by the engineer. So what Tim has said from this incident is that the real learnings, although there are learnings about structural integrity and how to build these joints, the real learning is universal to all different types of projects and major organizations. Projects are complicated, whether you're building a large building or whether you're building a large process facility. Things will come up during construction that you haven't foreseen in the design, and sometimes those things will require changes. You need to have a robust management of change process to handle all of these engineering queries or management of change requests, however you would like to call them. But you need to have a robust process, and that is the real learning from this incident. And so then that got me thinking, well, what other instance could we reflect on where we could have had the same learning? And as I've spoken before on these sessions, Trevor Kletz's quote where he said, there are no new incidents. If you've had an incident, just tell me what it was about. I'll open my drawer and I'll find a previous report, change the heading, and there you go. That's the findings. And I strongly believe that that is true. And so I had a reflection and I thought, well, what else within the process industry could we have learned the same lesson? So I've got two examples to talk about today. The first one was the Bhopal incident. Now, I know that the Bhopal incident was mixing of water with a chemical which made a large gas cloud, but there were a lot of things which were triggered, which could have triggered a management of change, where the change was not really adequately evaluated. And if it had, the incident may not have been as bad as it could have been. So some of the changes that happened during the design were that the materials of construction of all of the equipment used in the facility were different to the materials of construction that they used at other similar facilities in different countries. The reason that they made the change was to save money, and I suppose the supposal during the design was that they would repair things upon failure. However, for example, the water curtain or the scrubber vessel was not turned on. And the reason it wasn't turned on was because there were some integrity issues with it associated with corrosion because of the material selection. If they had repaired that, or if they had made it with the same materials as they had made other facilities, potentially the scrubber could have been on that day. The refrigeration system, again, had some operational issues, and the water curtain was not high enough to reach the gas. So considering the topography, which was a change from the previous projects to this project, considering the topography and whether the safeguards that they'd previously had as they were designed would have been effective in this situation, would have been something that could have prevented the large number of fatalities. May not have prevented the loss of containment in the first place, but may have minimized the consequences. Okay, and again, the flare tower was also connected, but it had been removed from maintenance. And from memory, I believe the flare tower and the scrubber had had some material changes from the previous designs, which contributed towards the removal for maintenance. The other thing that changed was that you were installing this equipment in a country with a completely different safety culture to the countries which you had previously installed it. And although people are people and people do make mistakes, having a completely different safety culture can change the way in that we interact with equipment in the field. It can change the way in which we view the importance of repair orders on safety critical equipment. It can change our understanding of what a safety critical equipment means and how important it is to maintain it or test it. And so thinking about those things when you are doing your design, or if you're copying a design from one place to another, ensuring that you are not putting anything in there which will make this facility inherently unsafe. The next incident I want to talk about is one which I'm sure a lot of you have heard of. This incident was at LG Polymer facility in India, and it happened in May 2020. There were a lot of changes here which impacted this incident. The first change was that the organization over time had eroded their engineering competency within their engineering team. So they had moved people up from operator and technician roles into engineering roles, which is great for development within the company, but they had neglected to identify that there were certain critical competencies that people needed to perform certain roles. And over time, the whole organization then lacked certain critical competencies to assess engineering changes. The second change that happened was that in January, they had decided that they were having some problems with one of the pumps, and this pump was circulating styrene monomer in the styrene storage tank through a refrigeration cycle. The problem they were having with the pump was that it was getting clogged up with styrene foam particles, right? So this should have raised the alert that actually the styrene was reacting within the tank, and as a result, they should be doing something to minimize that reaction. Rather than raising that alarm bell, the question was, how could we continue to operate these pumps without having all these blockages happening? Previously, the suction for the pump was on top of the liquid level, and decided to change the suction location to the bulk liquid level, or at the bottom of the liquid level. This had the desired effect. When you switch the pump on, the particles which were on top of the styrene monomer were not drawn into the suction of the pump, and the pump didn't break down regularly or have problems. It was fine during the day shift because there were operators there to go and intervene, but on night shift, when we still needed the refrigeration because this was a hot location, on night shift, unfortunately, there weren't people there to go and restart the pump. So they used to switch off the refrigeration system on night shift so that people didn't have to try and intervene. So they did this change and it had the desired effect, but unfortunately it had an unforeseen effect, or an unforeseen by the team effect. The purpose of the refrigeration is to keep the styrene monomer below a temperature where runaway reaction would occur. The runaway reaction heats up the liquid and then will vaporize the styrene monomer, which is a toxic gas. The toxic gas cloud then can travel into the surrounding populations, which is what has happened on the day. By moving the suction of the pump to the bulk liquid level below, unfortunately, what happened was they removed the mixing process, which happened in the tank. So the bulk, the suction was next to the discharge of the pump, and basically it was a very short recycle. And so they were only cooling a small amount of the liquid in the tank. And so therefore the top layers of the fluid in the tank were able to get hotter and were also not mixed with the other layers. And as a result, when the reaction started to happen, those layers which were getting warmer were not being adequately cooled. Also, just the mechanics of the tank. So the tank was originally commissioned to store molasses. Molasses did not need refrigeration. It did not need safe venting because it was not a toxic gas generator. It did not need any mixing to make sure that we didn't have stratification in the tank. However, that tank was then repurposed for styrene monomer use later in life. When that repurposing happened, there weren't changes to the construction to enable it to be used safely for styrene monomer. And I know that the change happened a long time ago, But there were other tanks on the facility where these additional safeguards were considered. And there was no initiation then of the change, realizing that actually one of the tanks where we are storing styrene monomer, it's not really fit for purpose for the purpose of storing styrene. So for example, it had surfaces within the tank where styrene could condense in the vapor phase. And if the styrene monomer condenses in the vapor phase, it is not in contact with the inhibitor. When it's not in contact with the inhibitor, it then can polymerize. And when the particles fall into the liquid, that can cause further polymerization. It acts as a catalyst. So all of these things that were about the physical construction of the tank, then the change that happened in January, and then we also had this competence change. These things then contributed to when they restarted after the first pandemic lockdown. When they restarted, obviously there were loads of new safeguards to put in place associated with keeping people away from each other and making sure that people didn't catch COVID at work. If you remember, in May 2020, we were all terrified of this new virus, how it could impact people, and also that we could spread it at work. So there was a lot of change happening itself in the other parts of the facility. Also, before the shutdown, they suddenly shut down the system, and it turns out that they didn't have sufficient inhibitor on site. When they came back to start up again, the inhibitor concentration within the tank was lower than what it should have been. This, combined with the poor mixing associated with the tank, with the new suction location, resulted in significant hotspots. About 2 o'clock in the morning in May, the hotspots started to have runaway reaction and started to vaporize the contents of the tank. It was released into the area, and it was a still night, and people were impacted while they were in the area around the facility. So there were quite a lot of changes on this facility, and I'm sure that as we learn about other incidents, there will be other changes that have happened. So for example, I don't know if you have seen, there is a video from WorkSafe BC on a mushroom composting facility. On the mushroom composting facility, they provided a new pump shed for the pump, and they also changed the suction location for the pump. In doing so, they increased the potential blockage for the suction line, and they also enclosed an area which was not previously enclosed. When the maintenance team went in to do some maintenance and try to unblock the suction, they opened the line, and unfortunately there was H2S in the line, and it accumulated within this newly constructed shed. 2 people within the shed were impacted, and then because people were not aware of that type of hazard, several more people came into the shed, and it unfortunately resulted in 5 fatalities. So I'll put also the link for the WorkSafe BC. But when we're making changes on projects or existing assets, often we can think that the change is insignificant. Sometimes we don't even identify that it is a change. Identification of change is the biggest issue associated with management of change. If you don't identify it as a change, you cannot manage how that change impacts your process. And also sometimes we only think about downstream, but how can this change impact upstream? And also sometimes we don't realize that changes which are not associated with the process can actually impact the effectiveness of our barriers, or how people can perform and maintain, etc. Okay. So what should we do now? So today we've reflected on management of change, but we really need to take this as an opportunity to learn from the past. If you are concerned that your management of change doesn't have the right stage gates or has some problem with identification, check out my website, because there's a detailed article there on management of change and the different stages that you need during management of change. We need to identify the hazards. And when we know the hazards of our facility, it's very easy to identify when changes could impact those hazards. If we don't understand the hazards of our facility, we can underestimate the consequence of change on our facility and on the hazards. We need to understand them. So understand how they come about on our facility, what the potential consequences are, and how we prevent either them coming about, leading to loss of containment, or how we minimize the consequences through mitigative barriers. We need to actively manage them, and that includes during changes. And we need to be vigilant. If we think something is a change, it is better to take it to a management or change panel or to the engineers to evaluate whether it is a change, rather than to assume that it is not a change and then get a rude awakening later on. I don't have much more on this, so I'm going to open now for questions. I'll stop the sharing. And I'll open the Q&A. If you have any questions, let me know and I'll answer those in the Q&A session. Any of the links I'll be able to provide on the YouTube, and I'll also pop the links on LinkedIn in a post tomorrow or the next day. Does anybody have any questions? So I've had a question through the chat. How can we control H2S leakage scenario emergency response? So emergency basis. So the best way to ensure that you minimize the consequences associated with H2S is education. So almost every toxic gas release that we look at historically has more than one fatality. Most of those incidents, if it had only been the person who had been affected initially, the number of fatalities would have been 1. However, in almost all of those scenarios, somebody is impacted by the H2S, and then somebody goes to see if they're okay, and they're impacted by the H2S, and then somebody else goes and checks on them, and so on, and typically land up with 4 fatalities. In this case, there were 5. But the most important thing is education. There's some really good videos. So the one I mentioned, the WorkSafe BC, that's really good because it's not a complicated process. It's mushroom composting. So we could imagine that even that could be something that's just done down the road from us at our home. There's also 2 really good videos from the CSB. One is, I think it's called H2S or H2S hazards or something, but I'll put that link on. And that discusses the different ways in which you can detect H2S and managing H2S to ensure that you don't have a toxic release or have multiple fatalities. The second one is one about a fire within a penstock. So they were doing some painting within the penstock and they had a fire. So in this case, the toxic gas is not H2S, but nonetheless, it is a potential confined space where the toxic gas was, and again, they didn't do very good emergency planning. And the third one from the CSB, which I would recommend you watch on this one, is the one about nitrogen asphyxiation hazards. Again, the gas is not H2S, but the principles are the same. There's a potential for an atmosphere which could be fatal to accumulate, and then how do you manage that? Okay, so I hope that has answered those, and I'll put those links on there. Okay, I've had another comment from Anit Ban. Very important topic you touched on is skilled staffing and changing it. Should be considered an MOC. How can we identify hazards and manage that risks with less staff? So this is a topic I'm really passionate about, is changing people and then not evaluating their competence. We normally are quite good with operation staff or frontline staff because we consider them as frontline barriers. However, with engineering staff, management staff, people who have process safety responsibilities, we are not so good at managing their change. For example, I've moved to several different locations. I have had hardly any handover from the previous person. And when I moved on from mine, I didn't have any structure about what I should hand over. And I had process safety responsibilities within my role. How do I make sure I hand over that to the next person? What I would recommend here is to actually define which are the process safety roles and responsibilities within your organization. We need to do this in 2 phases. You need to know who's accountable. So who is the person who's going to go to jail if this goes wrong? That's the person who's accountable. And then you need to know who is responsible. So who is responsible to ensure that this process safety activity, maybe it's ensuring that the maintenance team are sufficiently resourced so that they can maintain the instrumented protective functions, making sure that the electrical team are sufficiently resourced so that they can maintain the electrical fittings so that we can maintain our hazardous area classification. Or maybe it's ensuring that the process team have sufficient understanding of the types of hazards associated with our process. Whatever the responsibility is, you need to define it and say who in the organization is responsible for delivering that. Now, that may be delegated to somebody else, but that needs to be defined. And then if somebody changes role, they know this is the list of my process safety responsibilities, and this other list is my other responsibilities. It is very important for me to hand over my process safety responsibilities, because if they are missed, we could have an accident. The other responsibilities, maybe they're financial, maybe we have legal, etc. But we understand the difference between process safety and other responsibilities. We need to update job descriptions based on the hazards at our facility, and a really useful document to be able to start to define the competence and the roles and responsibilities is the ICME Safety Center document on process safety competencies. I found that very useful framework for defining what level of competence different roles had, and then you need to feed in from your hazard identification process what the risks are at your site so that you have specific knowledge in the different teams, and then getting that into the job description and then initiating that as management of change. The other thing that I've seen work well is where you consider management of change as the same for all different types of changes. So if you have a document change, if you have an organizational change, if you have an IT change, all of these are managed through the same process. There are different initiators and different approvers. Okay, and you might put different rigor on different levels. In that way, the organizational change then becomes transparent with regards to managing process safety. Often when we do organizational changes, because people within the organization may be made redundant, there is considered too sensitive to disclose to a wider audience. However, it is so important to manage the process safety responsibilities. So documenting your management of change, I would recommend, and I would just recommend that you use the same structure that you use for engineering management of change, but maybe different initiators and different assurers, although you will need to have some common ones like the asset manager or the project manager. I hope that answers your question. If you have anything else, let me know. I've had a question about what training and certificates should be required for staff to implement process safety for industrial oil and gas sectors, and which are the best certificates for process safety. So there are several different ones already out there. There's several master's programs for process safety. And then there are also like the ICME Process Safety Fundamentals. There's also a 20 elements course from the Energy Institute. And then there is a course from the CCPS on their 20 elements. All of these are great courses, but whenever you take a course or whenever you're trying to skill somebody up, what I ask you to do is I want you to define what gap it is you want them to close. With the ICME course, the Energy Institute and the CCPS course, they're all great, but they are very generic. They are not going to be specific for your site, and they're not going to specifically tell you how to manage or identify the hazards at your site. So if your hazards are particularly different, maybe you use ammonia, or maybe you use ammonium nitrate. The risks associated with handling that are quite different to the risks associated with oil and gas. And if you're handling a lot of dust, again, that then puts a different perspective on your hazard management. So yes, there are courses out there where you can get generic understanding the processes, understanding the different topics associated with process safety management, but ask yourself the question of what you're trying to skill them up in. So what I would recommend for anyone who is going to be doing process safety responsibilities, and I'm not sure if you're referring here to somebody who is going to be a process safety engineer, but if you're going to be a process safety engineer, you would ideally have a chemical engineering background, but if you don't, at least complete a process safety master's, which gives you some of those core skills associated with chemical engineering. And then also to have a good understanding of your process. And that's either through reading through your safety case or talking with your process engineer, and also talking through with operations to understand how the facility is actually operated. If you're talking about other people who have process safety responsibilities, there should be quite a significant element of training on the job, okay, which relates to the hazards at your site, where the hazards are located in your facility, and what to do if one of those hazards are realized. So for example, if you have a toxic release, do you need to don an apparatus and run away? Which direction do you run in? How do you know which direction to run in? If there is a fire and you're in the crew, you need to know what the types of hazards are and how you would respond. So a large number of fatalities in the process industry are actually the first responders, and most of the time it's because they don't understand the hazards of the specific process that they were responding to. So it depends on who you mean, but I've given you a couple of answers there. And if you are a process safety engineer, if you check out the process safety with Louise video that I recorded with Nick, we looked at a career in process safety and the different courses and choices that you might make. A lot of training, etc., is on the job. So see about that. So if anybody else has any other questions, pop them in the Q&A. Mohammed has asked, any CCPS guidelines you suggest for effectively evaluating management of change? So the CCPS does have a specific guideline on management of change. I'm not that familiar with it. Also, the Energy Institute has a specific guideline on management of change. Both of them are useful, but actually I didn't find that they covered everything. So I've constructed a audit process or a process safety health check process. And when I went through the management of change from the Energy Institute, I found significant lacking in the different stages of management of change, because all of the stages need to work: the identification, the assessment, the evaluation, the execution. So the evaluation and engineering, the execution, and the closeout. All of those stages need to work effectively for you to have good management of change. And so I found some of those didn't have questions in the Energy Institute one. If you want to get in touch afterwards, I can talk to you through the management of change. We'll be running some courses on management of change later in the year. So keep an eye on the website or on LinkedIn. But if you're looking to do a specific audit on management of change, I can maybe share that one element with you if you get in touch. Does anybody else have any other questions? Management of change. Okay, so I've got a question. In algae polymer case, do timely addition of inhibitors, would that have avoided the polymerization? So the guidance from, there is a body who looks after styrene monomer transport and storage, and they have some really, really good guidance on storing styrene monomer. One of them is to ensure that you have sufficient inhibitor in, and the inhibitor is well mixed within your tank or within your fluids, and that you test that periodically and you do some temperature monitoring. So yes, if they had the correct concentration of inhibitor within the mixture, it may have avoided the runaway reaction. However, there were some issues associated with the physical construction of the tank, which may have invalidated that. So, for example, by moving the suction of the pump to the bottom, they added the inhibitor, I understand, from the top of the tank. And so if they had been adding the inhibitor, would it have got to all the layers and would it have mixed well now that they had changed the inlet of the pump and the discharge of the pump was right next to? So it was just mixing that very small amount or that bottom layer. It wasn't mixing with the top layers and because of stratification. So yes, if they had the right polymer concentration throughout the mixture, it would have prevented the incident. But unfortunately, there were some things which prevented that even mixing of the inhibitor throughout the system. And also they didn't have enough inhibitor in the first place. Does anybody else have any other questions? Management of change, the incidents we've spoken about, or anything else? I'll give you guys a couple of minutes and then if I don't have any questions, I'll wrap up. A lot of you will see that my activity on LinkedIn has increased again. And so I'll be looking to share the links that we've spoken about here today, but also to share links of other incidents and other learnings. So if improving your process safety knowledge is something you're interested in, keep an eye out on LinkedIn because we'll start to share a lot more information on LinkedIn. Okay. I'm going to switch the camera off for a few seconds, and if I haven't had any questions, we'll move on to the wrap up. I've had a question. How can we change our organizational safety culture? This is a big question, and it's something that everybody may want to do or may have an aspiration to do. The problem with organizational safety culture is it can be very difficult to change. However, it can also be very easy depending on your driver. So we've seen a lot of organizations where safety culture is changed overnight. And that's maybe because they have a new person in the team who has a very strong personality or a strong belief, loud voice on a specific topic. And that can change the organizational culture. Or something external happens. For example, the pandemic changed organizational safety culture for a lot of companies, and it has also changed the approach to mental health and safety on a lot of companies. With process safety, the trigger for changing your organizational safety culture is most likely a large incident. However, I would encourage everybody to try to change their process safety culture before that happens. What I have seen work well is, let me see if I can pull that picture up, is if we start to think about safety using STAMP. So we imagine that it is, here we go. We imagine that it is a control system. I'll share the screen. So this is a model that I use for managing process safety and implementing improvements in process safety culture. If you imagine that process safety is a control loop, you have a command unit which tells things what to do. So tells things what to do. You then have an execution unit, which then receives these signals, completes some activity based on the information received. And then there may be some feedback where we give the command unit some confirmation that we have completed what they've told us to do. We might want to do some independent checking on this, and this is called our independent feedback unit, which might be, for example, a pressure trip or a high level trip, which is independent to our normal level control. If we think about this in terms of process safety, and I'll share this now, we think about our engineering and structure. The engineering and structure for process safety has to be very clearly defined. If you have not defined how you are going to do process safety at this facility, it is very difficult to then drive frontline worker engagement. So for example, you haven't defined how you're going to do management of change, but you just keep telling frontline workers they need to be better at management of change. And they're like, well, how should I be better? What do I need to do? What does good look like? You need to tell them what good looks like. So this is the first step. You need to make sure that whatever element you're looking at, you have defined how you want that to be in your organization. You then need to engage with people, tell them what it is you want them to do. And then you need to engage the front line, i.e. get them to do it. And here we need to ensure that they have the right competence to do it. They have the time to do it, and they have the right tools to do it. So for example, if you tell them they need double valve isolation to enter into a vessel, if you don't have double valve isolation or facility to put positive isolation, they're not going to be able to do what you're asking them to do, and they're going to start getting disengaged. Or this internal feedback is going to start telling you things which are not true. Or it's not going to happen. You're not going to get the internal feedback because they can't give you the feedback that you want to hear, that yes, when I entered this vessel, I had positive isolation, or I used double block and bleed to install the positive. They're not going to be able to tell you that, so they're going to stop telling you anything. You need to also have your independent check, which might be your independent audit by your insurance company, or you might bring somebody independent outside to come and check that what we think is happening is actually happening. And that is where the culture element comes in. So if we identify that we have some conflict between what our independent audits are saying and what our internal audits are saying, we know that the environment in which we are trying to execute our process safety management system is not healthy. Okay. And that is where we start to identify problems with our culture. What I found in most organizations is that we have problems with engineering structure. We haven't defined everything we want to do. And management are not typically, although they think process safety is very important, they find it difficult to engage on process safety. So how do I talk to somebody about process safety? What does that mean? I mean, if I want to go and talk to somebody about holding the handrail or walking up a stair, I can imagine as a manager what I need to talk to them about, because I can imagine doing that task myself. But if you want me to go and talk to somebody about relief valve sizing, you want me to talk to somebody about instrumented protective what? Helping in that management engage with the front line by giving them some additional guidance can help kickstart your process safety culture into a positive gear. So I hope that's helped. It's not simple to change, but you do need to have a drive to change, i.e. either management have recognized that this is something important which you're not currently managing, or you have some external incident which is causing you to change the organizational culture. There's a quote that comes up a lot on LinkedIn: just doing the same thing and expecting the results to be different, that's never going to work. If you have a problem with your process safety or safety culture, you need to be thinking about doing something different. And actually, if you use this model, it might be one of these levels which has gone wrong. Okay. So does that answer your question? I've had another question. What is the responsibility of a process engineer in management of change? Is it just monitoring the change and making sure that the process is safe, or is he part of the MOC? Well, it's not a straightforward answer. It depends on the change. If the change is to the process system, then potentially the process engineer might actually be the owner of the change. He or she might be the person who's driving the change forward through the MOC process. If the process engineer is the technical authority, that is the one that is making sure that the process competence is covered within the MOC, then the process engineer will have the responsibility, in addition to partaking in HAZOP studies, preparing P&IDs if required, reviewing operating procedures or drafting operating procedures or changes, updating safety case, whatever is required as part of that change. In addition to that, the process engineer will have a responsibility when they review to confirm that the latest engineering standards applicable to that change have been applied in the change. So for example, if there is a change which could impact the relief valve of the system, then the process engineer, by signing the management of change when they give their assurance that the change can be executed in this way, is saying, hey, yep, API 520 and 521 latest revision is what I've used to make sure that the relief is sufficient on this system. If you're not using the API standard, maybe you're using the European standard, you're saying that as well. If there is a requirement for changes to firefighting, active or passive, etc., each engineer is saying, by signing the MOC, to give their assurance that the latest engineering standards applicable to that scope have been applied to that scope. It is the requirement that the latest standards are applied to changes. They are not required to be retrospectively applied, but they are required to be applied to changes. And by signing the MOC or reviewing the MOC, that is what you're doing, is saying that the way in which it's proposed to execute this change is in compliance with the international standards applicable to this change. So I hope that helps. It depends on the change. If, for example, it's a structural change and it doesn't impact the process, then maybe the process engineer is not involved at all. But if, for example, we're trying to change the level control valve sizing so that we can handle liquid a bit more efficiently through the system, then that definitely will be a process change. The process engineer may be the initiator, may be driving the change forward, and will definitely have some responsibilities associated with overpressure protection. What is the best standard or reference for process safety management? Is it the NIBOSH process safety management system? So I know that the NIBOSH has got a process safety management training, but I don't think that they have their own process safety management framework. If you're looking for a process safety management framework, there are 3 that you could use. The OSHA one, which is very compliance, which is quite compliance related. We've got the CCPS one, which is risk-based, and then the Energy Institute, which is risk-based. There may be others in other countries, but those are the 3 that I'm aware of. I generally try to use the Energy Institute one because the membership for the Energy Institute makes access to those standards quite affordable. The CCPS one, it's quite an expensive book, but you can get that book and get the requirements for that. But the engineering management one, the Engineering Institute one, was generated by a group of different organizations with different capabilities. So it goes from Shells and BPs down to very small operators. And so it's sort of the lowest common denominator, and it is structured in quite a practical way. So I hope that helps. If you're looking for a training course or a certification, there are several different certifications. The NIBOSH, you've got one from the CCPS, and then you've also got the Energy Institute training. What I recommend if you're looking for a certification, there are 2. One is getting certified on the safety life cycle, which is 61511. So getting a certified practical a participant CPSFE. So rather than a functional safety expert, getting the level below, and that will give you a good understanding of the safety life cycle. Or you can apply for chartership with a process safety bias. So, for example, with the Safety and Reliability Society, which is specifically focused around safety, or applying through the ICANE, which has a specific process safety chartership. So those 2 will also help you. Although if you have got gaps, you will then evaluate yourself against their requirements and try to close those requirements. Okay. We're just approaching 10:02 now. If you have any more questions, if you pop them in the chat quickly, I'll try and answer them. Otherwise, we're going to wrap up. I had somebody raise their hand earlier, but I didn't see. Yeah, so I've got someone's raised their hand. Have you put your question in the Q&A in the thing? I'll allow you to talk, and maybe you can ask your question if you want. Bharath? Bharath Kumar, do you want to ask a question, or has your question been answered? Yes, you can get in touch if you have some additional questions. Okay, so I'm going to share the screen for the last little bit. We'll wrap up. Okay, so when's going to be the next session? We're going to be looking at the next session on the 4th of May at noon, the UK time. Some useful resources are available on my website, free HAZOP and LOPA templates, but also there are several articles, and there is a detailed article on management of change there. Also, I'll be doing some courses in May, which will be coming on the website in the next couple of weeks. There are only going to be a limited number of places, so please, if you are interested in them, sign up to them. So it's hazard, HAZOP, LOPA, and process safety metrics. Does anybody else have any other additional questions before we go? Otherwise, I'll end the session here today, and then we can we'll catch up again next month. I have a question: which is better, NIBOSH or certified functional safety expert? It depends on what you want to do. So if you have a look at the process safety with Louise session that I did with Nick, in there we talk about some of the different pros and cons of the different courses and how you might then choose which one is better for you. If you want to be a certified functional safety expert, you'd be looking at doing things like functional safety assessments, or in some companies require you to have certified functional safety expert to be able to deliver HAZOP and LOPA. If you're not looking to do that, if you're an instrument engineer, it may be worthwhile doing certified functional safety expert to help you manage more efficiently your hazards on your site. But otherwise, just a practitioner would probably be sufficient. Okay, thanks guys. Have a great day. If anybody has any questions, I'll be here for another minute or two. And then, so we've got TUV certifications, a question about that. The TUV certifications are useful. There are various organizations which provide certified functional safety expert. So have a look at all of them and then see which fits for you. I did the Exceeder one, but there are a lot of different ones out there, and TUV is one of the certifying bodies. Okay. All right. Thanks, Pier Paolo. I'll see you guys all next time. Any questions, catch up with me on LinkedIn or send me an email. Take care.